The myth speaks of a 25-kilometer white leviathan known as the Sea Eater. But if it existed, it would be more than a monster. It would have to grow through defined biological stages, shaped by developmental physiology and deep-sea constraints. Let's follow one individual from its first cell to Abyssal Titan. Day 1. At 10 centimeters across, the Sea Eater begins as a macrolecithal egg enclosed in a dense protein polysaccharide capsule. Early cytoplasmic polarity establishes the anterior-posterior axis of its future elongated body. Day 60. Still confined within the capsule, gastrulation forms ectoderm, mesoderm, and endoderm. Longitudinal muscle precursors and a primitive digestive tract differentiate. Day 61. At 5 millimeters long, a transparent larva emerges into the water column. It swims using ciliated bands and feeds planktotrophically to sustain rapid mitosis. Year 2. Reaching 1 meter in length, ciliary propulsion is replaced by muscular undulation. Supported by a hydrostatic skeleton, the oral disc enlarges and a caudal fin primordium forms. Year 5. At 3 meters long, it enters a hyperphagic state. Accumulating lipid and glycogen reserves, its proliferative cell zones expand in preparation for morphogenesis. Year 6. At 5 meters in length, it descends into the colder abyssal layers. It secretes a mucopolysaccharide cyst as its metabolic rate declines. Endocrine signaling initiates a radical transformation. Year 9. Inside a 7-meter cocoon, paired limb buds arise via localized mesodermal proliferation. Radial cartilaginous supports reinforce the developing oral aperture, while anterior neural tissues thicken. Year 15. Emerging at 12 meters long, the juvenile displays 2 short arm buds. Its hydrostatic framework is strong enough to support accelerated growth. Year 30. At 50 meters in length, the arms elongate through sustained mitosis and muscle fiber hyperplasia. Adhesive epithelial ridges and suction musculature enable active predation. Year 80. At 500 meters long, a posterior growth zone drives continuous axial tissue addition. The caudal fin hypertrophies to enhance propulsion in abyssal currents. Year 200. Reaching 1 kilometer in length, coordination relies on a distributed ganglionic nervous system. Radial oral musculature generates immense negative pressure for suction feeding. Year 480. At 5 kilometers long, reproductive tissues mature along the coelomic lining. Collagen reinforcement thickens the body wall to withstand hydrostatic pressure. Year 1500. At 20 kilometers in length, indeterminate growth continues at a rhythmic geological rate. Its massive arms extend for kilometers, functioning as sensory arrays and predatory appendages. Year 1979. At its maximum lore size of 25 kilometers, endocrine cascades trigger the release of millions of encapsulated gametes. Rising into the higher pelagic layers, the sea eater ensures the continuation of its mythic lineage. Year 2000. Still measuring 25 kilometers. Cellular repair declines as oxidative stress accumulates. Upon death, its colossal body sinks into the abyss, forming an unprecedented deep-sea detrital ecosystem. If the sea eater were real, it would not defy biology. It would represent its most extreme expression in the silent depths of the ocean. And if you enjoyed this kind of speculative deep-sea biology, make sure to like the video and subscribe for more explorations into creatures. Stay curious.